So we've been talking about how do I solve trig functions, and when we've been talking about how we solve trig functions, we've always had sine, cosine, or tangent of x. Now we're going to look at what happens if we have an expression, if we have that kind of bx plus c. And remember, we've looked at that before, and we've seen that when we have that, it shifts our graph around, which means it's changing our corresponding x and y values. So what we're going to do is we're going to say, what if I replaced this expression with a single letter so that I could use my unit circle and I could solve for it, since our unit circle consists only of sine of x and cosine of x, not sine of bx plus c or cosine of bx plus c. Then we can go back, use the unit circle, and then go back and resolve for our original expression or our original letter. One thing to point out is when we use substitution, we will always start with the general form, even if we're asked to solve for values in an interval. So this can be sometimes a long process. So let's go ahead and look at example 1. So notice example 1 is not in an interval. So first thing I'm going to do is I'm going to say, I really don't want that 3x. So because we're going to use the letter u in calc next year, I'm going to go ahead and use u now as well. I'm going to let u be equal to 3x, which means I can put u in place of this 3x. So I'm going to say cosine of u equals negative 1/2. And now I'm going to go to my unit circle and I'm going to ask myself what u value or values would give me a cosine value of negative 1/2. Well, I notice, and I have to write them both, I can have a u value of 7 pi over 6 plus 2 pi n, because I can rotate around as many times as I want to get back there. Or I can say u is at 11 pi over 6 plus 2 pi n. But as I mentioned before, I do have to go back and solve for what I originally was asked about. And I was originally asked about cosine of 3x, not cosine of u. Well, since u and 3x are equivalent, I'm going to go ahead and I'm going to take that 3x and I'm going to put it in place of u. I'm going to put it back in for the u. And I'm going to put it in on both of them. And now I'm going to go ahead and say, okay, so to get x by itself, I'm going to multiply both sides of my equation. I'm going to multiply this side and this whole side by 1 over 3. And I'm going to do the same here. So then now I'm going to have just x equals 7 pi over 18 plus 2 pi n over 3. And there's my new general solution, or at least part of it. The other part would be this equation here, which would be 11 pi over 18 plus 2 pi n over 3. Going ahead and looking at example 2, I'm going to do the same thing, because notice in example 2, once again, I have sine of an expression. So I'm still going to start by isolating that trig function. So I'm going to go ahead and subtract 1 and divide by negative 1. So subtracting 1 is going to give me a negative 1. Dividing by a negative is then going to give me a positive 1. So I get sine of 2x equals 1. Again, I have a trig function that is not simply just an x. It has that expression in there. So once again, I'm going to go ahead and I'm going to say, I'm going to pretend that u, or I'm going to let u be equal to 2x, so that then I have sine of u equals 1. Because now that I have sine of just a single variable, I can go ahead and look at my unit circle and say, when does sine equal 1? Well, sine equals 1 only at one spot, and that happens at pi over 2. So I'm going to say u equals pi over 2 plus 2 pi n. But once again, I was never really asked about u. I was asked to figure out some information about 2x. So I'm going to put 2x back in for u and solve for that x value. And I have 2x equals pi over 2 plus 2 pi n. And once again, in order to get that x by itself, I can multiply both entire sides by 1 over 2. It distributes in on the right there, giving me an x value of pi over 4 plus the 2's will cancel, so just pi n. Now I have to go back and say, okay, it was supposed to be in an interval, so I'm going to start plugging in some values for n to find all my values within my interval. So I'm going to go ahead and I'm going to plug in. I'll start with a 0 for n, and then I'll plug in an n equals 1, but start with 0. So I plug 0 in for n, and I get x equals pi over 4, which is in the interval from 0 to 2 pi. And then I'm going to plug in n equals 1. I'm going to have to do a little bit of scratch work for this. I get pi over 4 plus pi. So that is going to be pi over 4 plus 4 pi over 4, so 5 pi over 4. And then I'm going to plug in 2 for n. And notice that this is within my interval from 0 to 2 pi because once I hit that endpoint of 2 pi, that's going to be 8 pi over 4. So as long as I'm within 8 pi over 4, less than 8 pi over 4, I'm within that 2 pi interval. So when I plug 2 in for n, I get pi over 4 plus 2 pi. Well, that's the same thing as 8 pi over 4 plus pi over 4, which is 9 pi over 4. Well, as I just said, I have to be less than 8 pi over 4 in order to be within my interval, so that will not be a solution, so these are only going to be my 2 solutions in that interval. So again, even though it was solving for an interval, when I use substitution, I still have to start with that general form. Looking at one final example, I have sine of 2x plus pi equals 0, so I already have my trig function alone, but I notice that I have an expression there. So I'm going to go ahead and let u equal 2x plus pi. Then I have sine of u equals 0. I can use my unit circle, and I see that sine is 0 at 2 places that are exactly pi apart, so I only have to list 1 and say plus pi n. So u equals 0 plus pi n. So in other words, u equals just pi times n. Again, I have to sub my 2x plus pi back in for u, giving me 2x plus pi equals pi n. So I'm going to subtract a pi, giving me pi n minus pi, and divide by 2, giving me x equals pi n over 2 minus pi over 2. And now I'm going to go ahead and plug some values in for n because I want to find all my solutions within this interval. So I'll start by plugging in n equals 0. When I do, I end up with pi times 0 over 2, so 0 subtract pi over 2. Well, notice that that gives me a solution of negative pi over 2, which is not in my interval starting at 0, so I'm not going to count that one. So I'm going to plug in n equals 1, giving me pi over 2 minus pi over 2. Well, that equals 0, which remember a parenthesis means that point is not included. So x equals 0 does not work either. Now I'm going to go ahead and plug in n equals 2, giving me 2 pi over 2 minus pi over 2. Well, that's going to go ahead and give me pi over 2. And notice that that is finally within my given interval from 0 to 2 pi. I'll plug in n equals 3. 3 pi over 2 minus pi over 2. Well, notice that that's going to give me 2 pi over 2, which is just pi. And I can continue plugging in, but notice I'm changing by a factor of pi over 2 every time. So negative pi over 2, 0, pi over 2, 2 pi over 2. So I'm going to go ahead and predict that my next value when I plug in an n value of 4 is going to be 3 pi over 2. Then my next value will be 4 pi over 2. Well, 4 pi over 2 I know reduces to 2 pi, and since I cannot include it with a parenthesis, only with a bracket, that doesn't count, so these are going to be my 3 solutions within my given interval. So I'll go ahead and circle those and stop there. So again, always start with your general solution, and if it asks for values within an interval, just go ahead and start plugging in n values and make sure that you're only keeping the values that truly are in that interval and stop once you get to the end of the interval. Again, oftentimes you can start to notice the pattern. How am I changing each time? Then you don't have to do quite as much scratch work. You can just start listing your points, again, stopping at the end of your interval. And that is it for solving with substitution. I will see you in class.